In this video, we'll discuss about find all duplicates in an array. First, let's understand the question. Given an integer array nums of length n, where all the integers of nums are in the range 1 and n, and each integer appears once or twice. Return an array of all the integers that appears twice. You must write an algorithm that runs in O(n) time and uses only constant auxiliary space, excluding the space needed to store the output. So what they're saying is, we are given an array 4, 3, 2, 7, 8, 2, 3, 1. Now the numbers, the elements of this array will always be in the range 1 till n. Here n is the length of the array, which in this case is 8. So all the numbers are in the range of 1 and 8. And every element in this array will either appear once or twice. Now you need to identify what are all the elements that appear twice, and then you need to return them. So if we see here, 4 is coming only one time, 3 is coming 2 times, so we'll include this in our result array. 2 is coming 2 times, so we'll include 2 also. 7 is only one time, 8 is only one time, 1 is also only one time. So this will be our answer. Now what they are asking us, they're asking us to write an algorithm that runs in linear time complexity. Means O(n) of time it should take. So for that, we'll have to identify some good approach to solve this. So if you see, we have got one catchy point in the problem statement, which is that all the numbers in our array will lie in the range of 1 and n. So how we are going to use this? If I write the numbers here, 4, 3, 2, 7, 8, 2, 3, 1, and I give it I'll give it some indexing. So I will give it 1 based indexing, 1, 2, 3, 4, 5, 6, 7, 8. Not 0 based, 1 based. Okay. So now if you see that the index as well as the number will always be in the range of 1 and n, right? So can we somehow use these indexes to identify which element is appearing once and which element is appearing twice? We can do that. Now how are we going to do that? So what I'll do, I'll come here, I'll check 4. Okay, I'm at 4. So what I'll do, I'll go to the index 4. I'll go to the index 4, and whatever value is present at the index 4, I'll multiply it by -1. So this will become -7, right? So why I am doing this? See, this will tell me that if a number is negative, that means the index at which that number is present has appeared once in our array. Okay, whenever my number is negative, this will indicate that at whichever index this number is present, that index has appeared once in the array. Since now we have encountered 4 one time, right? So that's why at the 4th index we have a negative number, right? So now if we move forward, we have got 3. So whatever value is present at index 3 will multiply it by -1. So we will get -2. Now we'll move on to 2. So whatever value is present at index 2, it will be multiplied by -1. So it will become -3. Now we'll move here. This is 7. So we'll go to index 7. Now this will become -3. Then we'll move here. So whatever is present at 8, that will become negative. Now I'll come here. Now this is 2. Now if you see, at the 2nd index, we already have a negative number, right? And what was negative number indicating? Negative number was indicating that this particular index has appeared once, has already appeared once in my array. And now when I'm checking for 2 again, I am seeing that the number is already negative. So that means it was encountered earlier also, and now it is encountered again, which means this particular number is appearing twice in our array, right? This number is appearing twice in our array. So we will count this number. Not count, we'll push it in our resulting array. So we'll push 2. 2 will be in our result. Then we'll go to 3. Now at 3 index also, the number is already negative. So we'll push 3 also. then we'll go to 1. Now at index 1 it was positive, so we'll do -4. So we have traversed the entire array and this came to be our output. So this is how we are going to approach this problem. So now here we have considered 1 based indexing, but while you will code, your vector will be having 0 based indexing, right? So there we need to we'll do -1 to convert it, right? So what we are going to do is we'll loop from 0 till end, and we'll check that if my ARR of absolute of ARR of I -1 is less than 0, right? So what I'm doing here is, first I'm doing the absolute of ARR of I, meaning when I am at 4, I want to check that at the 4th index is the value negative or positive, right? Now these values we are changing to these negative values also, right? So it might be possible that ARR of I is negative. So that's why I am taking the absolute, because indexes will always be positive, right? They can't be negative. So that's why I have to take the absolute. And since here we have 0 based indexing, that's why I will have to do -1. Okay, so this will give me 4th. This will give me 4, and then ARR of 4 will give me the 4th index value, which is 7. So it will check, is 7 less than 0? No, it is not, right? So if in case that value is already negative, that means we have encountered this number before, right? So if I have a vector, let's suppose answer, which I have created, so I'll do answer dot pushback absolute of, right? We are giving positive number here, not negative. So absolute of ARR of I. Okay. Now if it was not negative, that means we are encountering it for the first time. So in that case we need to multiply its value by -1. So here what we'll do, ARR of absolute of ARR of I -1 into equals to -1. So we'll multiply the value by -1, and at the end we'll return our answer. So that's how we are going to approach this problem. Now let's code it out. So first we'll create a vector answer, then we'll loop inside our nums vector. So nums dot size I plus plus. Now we'll check that if nums of absolute of nums of I, right, -1 is less than 0. If it is, then answer dot pushback absolute of nums of I. And if it is not, then what we'll do, nums of absolute of nums of I -1 into equals to -1, and at the end we'll return the answer. Now let's run it. So here if you see, we are only iterating once, so our time complexity will be O of n. Now let's submit it. So it got accepted. Thank you so much for watching.